Students, we are going to start the lecture number 4. In the last 3 lectures, what you have seen is basically the brief descriptions of MI, that is material informatics, and in the last lecture we started discussing about regression. That is the first technique of machine learning which is used for informatics. As you know, machine learning is a broad topics. We are going to discuss some important methodologies of machine learning and deep learning for your purpose in this course. And if you really want to know details about these methodologies, you can always register in my other course, that is on AI/ML in materials engineering. So, in this course we are going to talk mostly about regression and kind of wind up regression and start discussing probability classification in the next lecture. That is the topics of discussion today. So, as you know, we are discussing about data driven discovery of design, development, even new materials, even the deployment also. And traditionally we use the trial and error, that is the experimental based technique to design or discover new materials, and it takes a lot of time, a lot of energy, efforts. So, the fourth paradigm which we discussed in the second lecture is the data driven approach. It consists of using data, process the data to design new materials. That is the key aspects, and the design process we do not need to do any experiments, we do not need to do any trial and error. We can actually use different kinds of methodologies from the data. Obviously, we use the data and then apply different kinds of models and methodologies to extract information to discover new materials. That is the key aspects of this. And as you know, AI is changing the whole world, whatever we perceive today, and the main component of AI is machine learning and deep learning. These are the two main components. So, most of our discussions in the initial lectures will be based on the models of machine learning and deep learning. I just want to go first through these things, and we discuss about machine learning, but let me tell you that machine learning is a process in which you use data, or we use experience data. Let me go back to the slide. It's basically a computer program which learns from experience E with respect to certain task and performance parameter P in such way that as the machine learns, its performance improves or P improves. So, experience is basically coming in the form of data, and data is nothing but a set of records. We call each record as a sample or instance, as you know, we can call that. Data can be temperature, time, stress, strain, it can be even diffusion coefficient versus temperature, we talked about in the last lecture. So, each of this data is called instance or the sample, and we have a data set consisting of many such instances. So, just to give you some kind of idea, when you do an experiment, some of you who are doing experiments, what do? You record certain things as a function of temperature, time, or maybe some other variables, right. So, that is what is your data actually. So, you record it, you can either record from experiments or you can record it from simulations. That is consisting of your data set. So, data set can be very big, it can have thousands of data, it can have 10,000s of data, it can have even 100,000s of data, or it can have less than thousands of data. So, our starting point is data, and machine learning basically uses data as an experience to learn the trend of the machine of the data and find out what the correlation among the data for certain task and with improved performance. That is what it is. To give an idea, here I have written that if you have x and y data, x and yi, x and y is the I sample data, and where xi is basically independent variable and y is a dependent variable. We call the y as a level or response and xi as an independent variable, right. That is what we call them. So, once you have that kind of methodology, what you do is that We first take the data from various sources, do some kind of feature engineering, looking at which are the parameters which are important, playing an important role in the certain kind of data sets, and then build a model based on that. That is what we are doing. Regression is one such model, and once you build a model, you can actually test the model whether the model is working well or not, simply by calculating errors of the prediction of the model versus the actual data. And then if it works fine, you can deploy the model. That is what is the main machine learning workflow is what is we talk about it. I discussed about this in the last lecture also. Data generation or data collection, then data engineering followed by model training, model testing and deployment. That is the key aspects of any kind of machine learning workflow. And machine learning can be two types, either supervised learning or unsupervised learning. Supervised learning means it basically develops a predictive model when you have both the input data as well as output data. That means both you have input data as well as your response, both are available with you. Okay, like if you are collecting temperature data of any kind of a sample as a function of time, the time and temperature both should be available to you. That is what is called both the input variables time as well as the output variable whatever you are measuring, temperature or stress whatever you are measuring. Both should be available with you, then you can develop a supervised learning technique. The two important supervised learning techniques which we are discussing here is regression and classification. So, part of classification you can discuss various kinds of models. On the other hand, you can also have unsupervised learning, that is it, that is where when you have only input data, you do not have the output or response data, only X data you have, let us suppose, you do not have Y data with you. What do? You can actually do unsupervised learning. One thing is called clustering. What is clustering? Clustering is nothing but grouping the data based on self similarities. We will discuss about details about that. So, basically most of the machine learning models which use in material science engineering, they fall under the category of supervised learning. There are few models which falls on unsupervised learning, which we will discuss also in the course of time. So, you can see that there is a certain distinct difference between supervised versus unsupervised. Supervised learning means it works under supervision, that means you have a training data which is nothing but observations of measurements, they are accomplished, okay, they are collected and then this data are used to develop a model. In case of unsupervised learning, there is only input data available, no class level or response available with you, and given a set of measurements or observations, we can establish only certain kind of a correlation among the input data. Clustering is one such aspects. Okay, so I just want to discuss more on regression. That is what we are doing that. Let us talk about it. And before we start regression, we already given an example. So let me just tell you few important aspects of regression in simply using some kind of chart. Let us say this is the plot tensile strength versus hardness. We know that tensile strength, that is yield strength of a material, is related to hardness. All of us has idea that 1/3 of the yield hardness is what is called yield strength. So here I am showing you some data points in which tensile strength is varying as a function of hardness of any material. Now I want to form a relationship between these two, right? The best possible curve I can draw, which is passing through all the data points. Can we actually talk about this relationship using regression? That is the key idea. Can I have a regression analysis of that? Okay. Or let us talk about stress versus strain. Here you can see that stress versus strain of a material at different grain sizes. Here you can see on the left side so many data. All of us know the relationship. Relationship is basically nothing but sigma is equal to k epsilon to the power n. But let us say we do not know the relationship. We want to find the relationship, right? This is a non-linear relationship, by the way. So therefore, we need to basically find out some kind of correlation between stress and strain or stress and elongation by using analysis of data. That can be done by regression. On the right side, I am showing you data of yield strength Ys versus grain size. And forget about this relationship initially, do not look at it at the beginning. This is the data points with error bars, and you can see that best possible curve can be drawn like that. So, that also means we are finding a correlation between grain size and the yield strength of the material, and that correlation talks about d to the power minus 0.066. We know that actually Hall-Page talks about 1 by d to the power half, right? We know that. So, Hall-Page relationship is typically like this, okay, or we can write down like this, correct. So, finally, is basically fitting the data. Regression is like that. So, when you have this such kind of data, what is the association between y and x, the independent variable with the dependent variable? How can I change, how can the changes in y be explained by the changes in x, or is there a functional relationship between y and x? That is what is the idea of regression, right. And simple example is y is equal to b1 x, a straight line passing to the center is origin of this curve. You can see that the slope is given by b1. This is the most simplest possible example of regression. In this case, we are trying to draw a line between these data points, which is passing to the center origin of this curve, right. So, now we can also have different kinds of straight line or standard straight line, like y is equal to y0 plus b1 x, y say b0 actually, not y0, b0 plus b1 x, and b0 is the intercept. You can see here, this is the intercept on the y axis, and b1 is nothing but the slope of the line. This is also an example of regression, linear regression fundamentally. If you want to develop polynomial or non-linear regression, you can have 3 coefficient y is equal to b1 b0 plus b1 x plus b2 x square. So, where b0 is the intercept on the y axis, b1 is a linear coefficient and b2 is the quadratic coefficient. Quadratic means x square term, right. So, what you have seen in the last few slides, that relationship between two variables x and y can be determined in different forms of equations, and these equations actually talks about regression. Now, once you form an equation, whether it is a linear or non-linear, your task will be find out the best values of this coefficient b0, b1 and b2. That we have discussed how it is to be done, am I right? You can have even much complex non-linear relationship like sinusoidal curves. You can see this is basically taken from book, and where the stress is varying as a function of strain and in a sinusoidal manner. So, we can write y is equal to b0 plus sine of b1 x plus b2 x square, or even more complex. This is also highly non-linear trigonometric relationship. This also basically talks about how we can actually determine such a kind of things. So, there are different kinds of curvilinear relationship possible, some of them I have shown you. So, now we go back to the board and talk about the best possible examples of regression, right. Let us talk about that. So, as you understood, regression is nothing but what? Between relationship between x and y. If I have data points, between x and y, so we can find out relationship between x and y. So, if I have plot between x and y, x is the independent variable, y is the dependent variable, and you have data points. So, you want to find out a correlation between x and y. That is what is done by regression. Am I clear? This is considered one of the simplest but elegant statistical methods in which we can estimate the quantitative relationship between y and x. Am I clear? And it basically allows us to find a simple mathematical relationship. Once we find out the mathematical relationship, we can predict the values of y for new value of x. That is what the machine learning does. Machine learning will like to predict values of y for a new value of x. Upon knowing the relationship between these two variables, it can do very easily. So, you have a data set, let us say, I write it xi where I goes to 1, 2, 3 to n, and yi where I goes to 1, 2, 3 to n, where xi is the independent variable or input, y is the output variable or the dependent variable or the level or the response. There are many names of yi. We can call it response, level, dependent variable, output. You will find many names in the textbooks, and x is your independent variable, right. So, we are trying to find out correlation between these two. That is what is the regression analysis does. Okay. So, very simple way I have written yi is equal to a plus, sorry, not a, w naught plus w1 x. Same as in the slides I have shown that yi is equal to b naught plus b1 xi, where b naught or w naught are same. These are two different sets of equation, nothing but. So, this is intercept, this is also intercept, this is slope, this is also slope. y, b1 and w1 are the slopes, and b0 and w0 are the intercepts, right. That is what we know. And we want to, if we want to find out the relationship, we need to figure out what is the optimum value of w0 and w1. That is the key aspects of regression analysis, how to do that. Okay. So, therefore, what we try to do is very simple. Okay, let us say you have m inputs, sorry, n inputs, y to n, right, we have already written n inputs xi, which is going on to like that. You have n inputs and also similar number of n outputs. So, I can write down inputs as x1, x2, x3 up to xn, and similarly n output, which is y1, y2, y3 and yn. So, I can write down the best, the simplest one is basically linear relationship. What is that linear relationship? Basically, I can write on yi equal to w0 Very clear. This is much better, is it not? You have different xi values, x1, x2, x3, xn. So, we can put against each x one coefficient. So, if I have to expand this is very simple, w1 x1, w2 x2, w3 x3 goes on. So, you can clearly see the simplest form was w0 plus w1 x, right. That is for each individual. But if I want to generalize this is what you should be writing. This is the most general equation, linear equation in regression, that is w0 or w0 plus sum it over j1 to n wj xn, and that can be expanded to this. That is how actually you can find out better correlation between the two data sets, two variables x and y. So, here you have so many w's that we need to figure out, find out. Okay. I will tell you how it can be found out w's very easily, but first thing you try to understand this relationship, which is the fundamental of regression analysis. Okay. So, any kinds of data sets you have, at the moment you want to find out the best possible linear relationship, you need to do this analysis for yourself. Okay. So, now the question is, how do I find out what are the best values of the W. That is what we call as the method called residual. Remember that it is called residual square, residual sum of square, and we have to minimize the residual sum of square, right. So, what you do? Very simply we can actually think of find out. Let me erase this to explain this. So, what we do is very simple, we call it to find out W's. I write down. What you use is called minimization of residual sum of square. So, you try to understand residual sum of square. What is that? What is residual? Obviously, residual is what? This is my predicted value. This is my predicted value. Okay. So, we take difference between these two and write down like this. So, like RSS we always write W within the bracket because that is what we want to find out. That is basically residual square is basically what is that? Let me write down properly, otherwise I will make a mistake. I1 to N yi minus is it not? That is what is the residual sum of square. You can see that this minus everything, right. So, this is what is the residual sum of square. We have taken the square also. So, we want to minimize this. So, what do you do? Minimization principle very simple, d RSS W by dW 0 is 0, first derivative, right, d RSS W by d Wj. That means for every j we have to do that. See, if I have to expand this, I can write down p of them for your purpose. You keep on getting this first order differentiation of residual sum of square respect to W0, W1, W2 and go on. So, what will happen? Finally, for each of these will, if you put it 0, that is what the minimization principle talks about it, you can find out the values of these W's. So, this is the technique which is used in regression analysis to find out the optimum values of W's. Please keep in mind that. This is the main idea behind regression. First, to form a generalized expression, and then from generalized expression we can find out the residual sum of square, and we minimize the residual sum of square. Residual sum of square is this. We minimize that. The minimization principle, if you go back to mathematics, tells you the derivative, first order derivative of this with respect to the variables like W0, W1, 2, 3, 4, whatever must go to 0. Once you do that, we can easily find out the values of W's, which are the best possible values. So, I hope it is understandable to you that this is the way regression analysis works. Okay, in a computer it is very easy to do, these are not difficult, but fundamentally mathematical part you must understand very well, because otherwise you will be using this the machine learning thing like a black box. We do not want to do that, because if you want to modify this, how will you modify that if you do not know the basic mathematical derivations which are involved for this. Okay. So, that is for the linear aspects of this. So, we will stop from here and we will go back to the nonlinear aspects, and also we will talk about what is the problem of using this approach. Thank you.